In section 6.4, we're going to be looking at ratios, proportions, and variation. The ratio and proportion piece you're probably already very familiar with. The piece you may or may not be as familiar with would be variation. So let's start with taking a look at reviewing concepts that you most likely have seen before. A ratio just compares two quantities using division. Then a proportion is a statement of equality of two ratios. So a ratio is comparing two quantities. A proportion is actually comparing two ratios, showing that two ratios are equal. How we solve proportions. Once upon a time, you learned this, that you cross multiply. Now some of you just learned cross multiply, divide. I like to just say you cross multiply, which means 22 times 7 equals 25 times x. We do a little simplifying. We get 154 equals 25x. Divide by 25 to solve. And we end up with x equals 6.16, or 6 and 4/25. Either way. Same thing in letter B. We cross multiply. So we have 48 times 5 equals 12 times x. 240 equals 12x. Divide by our 12. And we get x equals 20. So we might end up with decimal or fraction type answers. We might end up with a whole number or an integer type answer. The reason why I don't just say cross multiply and divide is when we come across something like letter C. Now letter C might not be a proportion type that you have solved before. We do our cross multiply, but we can't just jump right to the divide piece. We have a variable part of both of our ratios. So on each side of the proportion, we have a variable. So we can't just do cross multiply divide. We have to do cross multiply and then solve from there. So when we multiply 15 times x minus 2, we have to actually do the quantity x minus 2. So we do have to put x minus 2 in parentheses and distribute the 15. Same thing on the other side. 5 times the quantity x plus 6. We have to end up distributing in order to solve this. So knowing to cross multiply and divide for something like A and B works perfect. But for letter C, we have to cross multiply and then actually solve. And you can go about solving however you would like. I like to move my variables first, but it's entirely up to you. And I'm going to run out of space. I end up with 10x equals 60. And x equals 6. So I'm sure you're very familiar with solving proportions like A, B, and C, or excuse me, like A and B, but C you might not be so familiar with. Also keep in mind, these are simply equations. So once you get a solution, you can substitute it back in and check. Make sure the ratio on the left equals the ratio on the right. A little bit of application piece with our proportions. We have the U.S. Department of Agriculture reported that 57 out of every 100 milk drinkers drink skim milk. If a store owner orders 25 gallons of milk, how many should be skim? So if we make the comparison of, and I like when I do proportions of the application piece, I like to label what each number represents. I need to make sure the labels in my proportions match up. So if in my first proportion, I have 57 skim milk drinkers out of 100 total milk drinkers, that could equal, we need to order 25 total gallons, and I want to know how many should be skim. So notice my labels match up. In my numerator, I have skim and skim. In my denominator, I have the total and the total. So both of my ratios are representing the same things. We do a little cross multiply to solve. And we come up with, we get 57 times 25, 1,425 equals 100x. And x ends up being 14.25. So if we just answer the question with 14.25, I will not give you full credit on your test. I'll give you credit for setting up the correct proportion, but you're not thoroughly answering the question. I can't, as a store owner, order 14 1/4 gallons of milk. So you would have to decide. I would accept, to be honest, I would accept 14 or I would accept 15 gallons. As a store owner, you feasibly could look at that and say, well, I think 14 should be plenty. Or if you want to ensure you have enough, you might go ahead and order 15. So to be honest, I would accept either answer for that. I could see it either way. A student can type 18 pages in 10 minutes. At the same rate, how long will it take the student to type 72 pages? Again, I like to label to make sure everything's matching up. So 18 pages for every 10 minutes will equal 72 pages after how many minutes? I like to label. I don't want you to fall into the trap of just always assuming your variable is going to end up in the numerator somewhere. It might not. This one, we actually have the variable down in the denominator, and it will work out just fine for us. We do a little cross multiply to solve. We get 720 equals 18x. Divide by 18. And we end up with 40 minutes. I will be looking for, come test time, I will be looking to make sure that your label is also correct. So it's great if you can set this up, you come up with an answer of 40, but I also want to make sure you understand what your answer represents. So you would need 40 minutes if this were a test question. Now onto the piece you might not be as familiar with. You've probably set up equations like these before, but maybe have never actually used the word variation. There's two different types of variation we're going to look at. We have direct and indirect. First type, direct variation. Y varies directly with x. If there is some non-zero constant, and we have to make sure we say non-zero, constant k such that y equals k times x. If k were 0, we would just have y equals 0 each time. So it has to be some non-zero constant k, so that y equals that constant times x. So for example, if a person drives 65 miles per hour, their distance y varies directly with the number of hours x that they drive. So y varies directly with x. So if distance varies directly with hours, distance is y, your hours is x. Here is what our equation would look like. Y varies directly with x. It means x is, as x increases by some constant, as x is multiplied by some constant, that results in your y variable, whatever that happens to be. So just another example with the direct variation. If a person earns $30 an hour, their income varies directly with how many hours they work. So the more hours they work directly affects their income. Their income increases directly by how many hours they work. So our equation, our y, what they earn, equals 30 times x. So the weight of a certain type of cable varies directly with its length. Y varies directly with x. So your y value will be the weight varies directly with the length, which is your x. So if 20 feet of cable weighs 4 pounds, find our k value, so that constant that we're going to change by. Write an equation of direct variation and determine the weight of 75 feet of cable. So in order to find our k, remember, y equals k times x. So we know we have 20 feet of cable. Length is our x. So I have 20 feet of cable that weighs 4 pounds. Y is our weight. So to solve this, we divide both sides by 20. And 4/20 simplifies to 1/5. So our k value is 1/5. So our equation of direct variation would be y equals, put 1/5 in for our k, times x. So we want to use that equation to determine the weight if our length is 75 feet. So our length is 75 feet. Length is x. So y equals 1/5 times 75. Our y equals 15, and again, I will be looking for the correct label. If y represents our weight, and our weight is in pounds, we need to make sure we label 15 pounds. The other type of variation that we can come across is called inverse variation. Y is said to vary inversely with x if there is some non-zero constant k such that y equals k divided by x. So instead of k times x, we have the inverse of multiplying by x. We divide by x. So it varies inversely. We've multiplied by the inverse of x, which would be 1 over x. That's why we see our x in the denominator. If the temperature of a gas is held constant, its volume y varies inversely with the pressure the gas exerts on the container. So we have the volume is y, the pressure is x, and we have it varies inversely. If the gas has a volume of 38 cubic inches and exerts 8 pounds of pressure per square inch, find k, write an equation of inverse variation, and find the volume when the pressure is 64 pounds per square inch. So we need to find our k first. So in order to do that, we see our equation at the top, y equals k divided by x. We don't know k, but we do know x and y. Y is our volume. So our gas has a volume of 38. We don't know k, but we do know x. X is the pressure the gas exerts. This exerts 8 pounds of pressure. So our x is 8. So to solve for k, to undo dividing by 8, we multiply both sides by 8. And we end up with 304 is our k. So y equals 304 divided by x. There's our equation of inverse variation. So now we want to find the volume when the pressure is 64 pounds. Remember, the pressure is your x value. So y equals 304 divided by 64. We get y equals 4 3/4 inches. But remember, our y is volume, so it's inches cubed. I will be looking for correct labels when it comes to application questions. Let's try one more with our inverse variation. The time it takes to drive a certain distance to a vacation home, y, varies directly with the rate of speed of the car, x. Varies inversely with the rate of the speed of the car, x. If it takes 5 hours traveling at 70 miles per hour to get to the vacation home, find k, write an equation of inverse variation, and find out how long it would take to arrive at the vacation home traveling at 60 miles an hour. So let's start with we need y equals k divided by x. And the first piece of this, it asks us to find k. So we have to pick out, we have 5 hours and 70 miles per hour. The time is y, so 5 will be y. And then the rate of speed is our x. So 70 miles per hour is going to be our x. Again, to solve, we multiply by 70 both sides. 350 is our k. Our equation of inverse variation, y equals 350 divided by x. Now we want to figure out how long it will take to arrive at the vacation home traveling at 60 miles per hour. 60 miles per hour is the rate of speed of our car, which is represented by x. And we end up with our y equals, as a 5.83 repeating, which would be 5 and 5/6. But now to answer the question, though, we want to make sure it asks us how long. I don't want to tell somebody, if they ask me how long it's going to take to get somewhere, I don't want to say it's going to take you 5.83 repeating hours. I want to be able to tell them hours and minutes. So in order to change that piece, we know it's going to be 5 hours. We need to multiply, and you can leave, if you have 5.83 repeating in your calculator, subtract off the 5, so you're left with just the repeating decimal in your calculator. And in order to figure out how many minutes that would be, we need to multiply by 60. And we get 50 minutes. You could also, if you figure out the fraction piece, you could also do 5/6 times 60. Will also give you 50 minutes. So 5 hours and 50 minutes would be the answer I would be looking for come test time. Again, 5.83 repeating hours, that's not very meaningful to me if I'm asking somebody how long it's going to take me to get somewhere. I want to know hours and minutes. Or if you want to even change the whole thing to minutes, I would be okay with that. I just don't want a decimal part of an hour. That's not very helpful. So just a little final summary. In the questions, folks, they will actually say varies directly or varies inversely. So that's going to be your cue to know which of the setups you need. If it varies directly, you're multiplying by x. If it varies inversely, we need the inverse of that, which would be dividing by x.